Now, if you go to the textbook, the 4 textbook, you're gonna see the 3 last chapters. They are about using cryptographic protocols in different layers of the network stack. Okay, so you have 1 lecture about using cryptography or security protocols at the transport layer. They called it. They considered this SSL-TLS. So SSL-TLS because it's just on top of TCP on top of transport layer. This is using protocols at the transport layer. Then they were using crypto protocols on the application layer, but that chapter will not cover. I don't think it's very relevant here because crypto protocols are used in so many application layer protocols, and the ones that are covered are not very representative because the book is 2007, so it's not very new. Although all the material like the AES, DES protocols, they are the same, okay? But for that particular protocol is quite chapters. For that particular chapter about applying security protocols on the application layer is not very recent, not very fresh, okay? The third chapter about using crypto protocols on the network layers is to use crypto protocols at the network layer. Okay? So this is IPsec, basically. IPsec, it is using cryptographic protocols at the network layer. Okay? So here, even if you as user is not using or not, for example, choosing HTTPS or some secure protocol, the system will provide you with encryption and integrity capabilities in a transparent way. So you are not aware of that. They're happening on the background, okay, at the network layer. So IPsec is designed to provide security at the network layer. Okay. So in IPsec, so basically here the idea is to protect the packets at the network layer. Okay, so IP packets, we try to authenticate them and encrypt them to provide confidentiality, basically. Okay, so there are 2 modes. We can do it in 2 different ways: in transport mode and tunnel mode. Okay, so in transport mode, IPsec protects what is delivered from the transport layer and to the network layer. So here, remember in the network stack, if you have something you need to send, this is your data. Okay, this is your data at the application layer. Okay, so what you do is split it into fragments, and we call them segments. Okay, and we give this to the transport layer. So here I want to turn it transport layer. So what happens at transport layer? Basically, you will take that data and then you do what?
Give it a socket.
Huh?
Give it an add a header.
Add a header containing the source and the destination addresses at the transport layer, which are what?
The port
numbers. Okay. And you add there any information needed by the TCP. Example of information apart from port, destination, and source port.
The protocol that used HTTP.
I see.
Yeah.
Is the packet fragmented or
Yeah. So information about the packet, the size, the window. TCP we deal with the congestion management. So everything related to the transport layer, you will have it here. Then this is considered the transport layer segment. Then if it goes down below the transport network layer, okay, you bring it to the network layer, and then you do what? This is your data at the network layer coming from the transport layer. So all this is your data you need to send. So you will do what on that? Add the IP header. So add an IP header. Okay. So we call AIPH here, containing information related to the network layer protocol. Now, in transport mode, what happens? In transport mode, you will protect just this packet, this content coming from the transport layer. Okay. So here, what is protected is just the payload of the network packet, network layer packet. Okay, the IP header is not protected. Okay, the information in the IP header is not protected. Okay, so so basically, IPsec transport mode does not protect the IP header. It only protects the information coming from the transport layer. Okay, so this is what happens. Basically, transport layer payload. This is what you get from the transport layer. You add a header and a trailer. Okay, the IPsec will add both things, a header and a trailer, and then it will add the IP header as normal. Okay, so the protection is only on that part. Okay, this is the transport mode. Yeah, so you do it, of course, when sending you do this, at the destination you do the opposite. Okay.
So how does it differ from the SSL and TLS? Is it very similar?
In SSL, you have some data that you need to protect. You need to encrypt, basically. It's about encryption. What you will protect? You have the data coming from the application layer. Then at the transport layer, you will protect the data at the transport layer.
Only transport. The payload of the transport.
Yes. Yes. The payload at the transport layer. Yeah.
So, but in this case, you still have the IP, the port number, everything. It's not.
They are encrypted. Port number, the IP source and IP destination, they are not encrypted. Yeah. But can you protect the? Can you encrypt the IP source and IP destination?
No, you need it to route.
You need that information to get that packet reach the destination. Can you now encrypt the port and source port and source destination?
Source port and source destination. Well, that's
the port destination.
It's your machine, so.
Yeah, because it already reached the physical machine, so you can encrypt it. It's not used to route the protocol. Okay. The second mode is tunnel mode. In tunnel mode, basically, you can guess the difference. In tunnel mode, basically, you will protect the IP packet entirely, completely, all the IP packet, including the header, including the IP header. Okay. So in tunnel mode, IPsec protects the entire IP packet. It takes an IP packet, including the header, applies IPsec security method to the entire packet, and then adds a new IP header. So here we are talking about two IP headers. One before protection, one after protection. Yeah. Because if you encrypt the IP header, the original IP header, you will not be able to route it. So you need to add another one. Okay. So this is what happens. This happens at the network layer. So once we craft our network layer packet, including the header, we will protect all that, and then we'll add another IP header for IPsec. Okay. Yeah, so it works the same way in the source and destination. So here, this shows you the difference. In transport mode, the IPsec layer happens between the transport layer and network layer. In the tunnel mode, is something internal to the network layer. It doesn't involve any other layer. Okay. Is it clear so far? So basically,
what is the difference between tunnel and transport?
what is the difference? Is it difference? I was explaining. What is the difference?
Yeah, when do you use the tunnel? When do you use the transport?
It depends. If you need to encrypt the or protect the network layer header, okay, the original network layer header for some reason, okay, you need to hide that. Okay, you use the second one, tunnel. If it doesn't matter, you use the first one. Okay.
Now, there are some protocols in the network layer. So when you encrypt when you use the tunnel mode, do you change the protocols that are when you generate?
You're talking about the protocols at the network layer.
Yeah, there's some protocols at the
Yeah.
network layer. They are available in the header.
It depends what IPsec is implemented here. Because we're gonna see what kind of information you will put in the headers, the IPsec headers. Among them, the protocol being protected. Okay, so you specify that. Okay. Okay. Now,
So I'm not spoofing the protocol. For example, if I have the ICMP protocol, I'm not using another protocol to say that, to hide it.
يعني IPsec, how it is implemented, you can do it. You can change the protocol because you say, okay, I will implement IPsec using, I don't know, ICMP, for example. Okay, so anything from using any other protocol, you will craft it into ICMP packets. Okay.
You craft it into IPsec.
No, sure. IPsec is not really a protocol.
Oh, I see. It's just.
Yes. So you need to use another network layer protocol. So IPsec defines two modes or two kind of protocols: authentication header and encapsulating security payload (ESP) to provide authentication, encryption, and integrity. Okay, integrity. Okay. So these are the three security properties provided by IPsec: authentication, integrity, and confidentiality. Okay. Now you have two protocols for that: authentication protocol and the encapsulating security payload. The difference is that so you have to choose one of them. Okay. The difference. The authentication provides authentication and integrity, but not privacy or confidentiality. It doesn't encrypt. So with AH protocol, there is no confidentiality. Data is not encrypted. Okay. You have integrity and authentication. Okay. ESP will give you the three. Okay. Now, how authentication header works? So basically, again, this is which mode is this? Tunnel or
You cannot say.
huh? You can say.
Transport. Because
Why transport?
it doesn't have.
So it's a tunnel.
Huh?
So it's a tunnel. If it doesn't have the IP address, it's a tunnel.
See here, you should answer by looking at this arrow here. Okay, the data used in calculation of authentication data. So basically, when you again authentication protocol or authentication header, it provides just authentication and integrity. Okay, so what you need, how to provide authentication
And integrity.
and integrity. What is the best way?
Signature.
Huh? You hash and we said authentication. You need to hash it with a key.
Yes.
You need to involve some key, either to digitally sign it, okay, or you hash it with using a secret key, okay, or a private key. Okay. Now here we are doing that, so we are calculating the authentication data, but out of what? Out of all this, and you see that it includes the IP header. So the header, the IP header, is protected. Okay, so this is what? This is tunnel mode, the first one, the second one, tunnel mode. Okay. Anyway, now how it works? Basically, what you do, you take all your data and then you compute a hash using a key. So keyed hash, a map, kind of map. Okay, and then you put that in the header of the authentication header protocol. In addition to your data. So when the destination receives this, it can recompute this hash, okay, and check. Okay. Now this is the content of the this authentication header or the AH header. Okay, you have like here. So, for example, you have a lot of information. We're gonna discuss them. You have payload length. You have a security parameter index. We will explain it later. You have a sequence number, and you have the digest. This is the digest. This next header, it specifies the original protocol. So if you are carrying out, for example, an IP or ICMP or UDP, it will that information will be here. Okay. Now you asked about. I'll come back to your question. So which IP protocol is used here? So it will not keep the same network protocol. It will not use a different one. It is implemented, basically by having its own network protocol, which is authentication. So basically, if you need to protect the ICMP, okay, it will be turned into authentication header packets. Okay, and AH basically is a network layer protocol. Okay. Now, do you notice something strange here?
Yes.
What is strange?
We said we will hash the whole thing.
Yes.
But then we will add the hash inside it.
Yes.
So the hash will.
So this kind of
Mixed.
this is called what? This is what? This phenomenon is called what? You know it very well. Huh? Recursive. It's recursivity. So there is something which is infinite loop here. Okay, basically because in order to compute this, you need to use the same information. You see? So it doesn't make sense. Okay. So how this is implemented? Basically, to compute this authentication header, you replace this by zeros initially. When you compute, you replace this by 0. You compute the hash, and then you replace those zeros by that digest. Okay. Okay. So another thing is that data used in calculation of authentication, except those fields in IP header changing during transmission. There are some information. There is some information that changes when you have a packet, IP packet. Okay. Then you send it through the network. It goes from router to router, from hop to hop, etc. Now, there is some information that changes from hop to hop. Give me an example of information that changes from hop to hop.
Next
Huh?
hop.
IP address doesn't change.
MAC.
Huh? The MAC, this is another layer. Here I'm talking about fields in IP header. MAC is not the IP header. It's the lower layer.
Next hop. Next hop IP.
Next hop, same thing. It's the problem. Is the
No,
problem
because
of
it deals with the routing protocols and the network.
So the
layer.
destination will be always the same.
yeah. So some, but do you include that in the IP header?
Only the first transformation.
So example of information that changes from hop to hop is TTL.
Oh,
The TTL, time to live.
Oh, yeah.
Time to live. You remember what's time to live? Time to live changed. So basically, you should not include it in the when you compute your hash because it changed. Okay. Now again, I will come back to this security parameter index. This is the one feature of IPsec. The second protocol in ESP provides authentication, integrity, and privacy. Okay, so three of them. So basically, here when we say privacy or confidentiality, we will involve a kind of encryption. So this is how it works. Basically, in ESP we add header and trailer. In authentication header, we just use one header, no trailer. Here we need a header and trailer, and basically similar to here. The mode here is what?
Yeah, actually.
What is the mode here?
This is not tunnel. This is not
Huh? What is the mode here? Is it tunnel or transport? It is transport. Why? Because the IP header is not part of the protection. It's not protected. Okay. So we can have the same example with tunnel mode here. On purpose. First example was tunnel mode. The second was transport mode. So you notice that by seeing if the IP header is protected or not. Okay. This is how to distinguish between tunnel mode and transport mode. Now, what is authenticated is all the data, including the header and trailer. Okay, what is encrypted? And see here the authentication data. The authentication data is not part of the ESP header. It is separate here. Okay. Now, what is encrypted is the payload and the trailer. Why we need a trailer here?
to check.
Right.
It is so here. Notice here the content of the trailer. It contains just padding. And when do we need padding? What does it mean padding?
Lock.
Huh?
The size is not fit.
Yeah. When the size is not multiple of what we want. For example, all the protocols we saw. You know, DES, AES, حتى الهاشم. Okay. RSA no. Or RSA.
It's a number.
Yeah, number. you might need also Python. You might need Python. Now, when starting from your data, you split it into equal size blocks. The size of your data should be a multiple of that block size. Okay, this is why you need Python. Okay, and here when we say encrypted, basically we're going to use symmetric key protocol, and symmetric key protocol always the size of block is fixed, like in DES. What is the size of block in DES?
64.
64 bits. 64 bits. Okay, so you need your data to be 64 bits, and this is why we need Python to make the data multiple of that size. Okay. Yeah. So this is it for ESP. Now you tell me, okay, why do we need two? The ESP is much better. It has all the the features we need. Okay, all the three security products. Why we need authentication? So basically, why we need two of them? Initially we had just authentication header protocol. Okay, when we designed IPsec, we had just that protocol, and people started to use it. And then, with the need of confidentiality, ESP has been designed, and now ESP is the standard, is most commonly used, and we still support authentication header because of a lot of old systems are still using it. Okay, but new systems are exclusively using ESP. Okay.
So AH does not provide the privacy feature.
It doesn't. Okay. So these are the services provided by IPsec using the two protocols. So we have access control. We will see how this access control is done in a couple of slides. Okay. Message authentication and integrity. Entity authentication. Message authentication. Basically, this is integrity, and this is entity or identity authentication. This is authentication. You have confidentiality, and you see the only difference between AH and ASP is that AH does not support confidentiality. And also, IPsec protects against replay attack. Remember, replay attack.
Refreshes.
Yeah, so replay attack, it consists in doing what?
Saving the same.
Recording certain packets, then replay them sometime later. Okay. So IPsec is equipped to protect against replay attack. It's done through what we call the sliding window. You remember that in TCP. TCP, we have a sliding window to make sure to decide when to ask the sender to resend the packet. Okay. So basically, here you have a sliding window that has a size, and then whenever you receive a new packet here, okay, your window will slide, okay, and you keep accepting all the previous packet up to a certain level, okay, up to a certain level. What happens if there is a packet here did not reach yet, and it is passed by the window? What will happen? So basically, the destination will ask the sender to resend it because it will send a kind of here it will be dealt with acknowledgement. If the sender does not receive an acknowledgement at the right time, it will.
The window should not move until the acknowledgement has been received.
Sorry?
The window should not move until the acknowledgement has been received.
Yes. To make sure if one packet has been received. Here you will talk. Yeah. Yes.
Before was it received then?
Yeah. Anyway, so basically the IPsec will work on this interval. Yeah. Now, how it is implemented? Until now, we did not discuss how this authentication is done, how this encryption is done, because when we covered SSL, before starting to encrypt and decrypt, we need to do what? We need to what first phase did we do in SSL?
Define protocol.
Before that, agree on the cipher suite. Yes.
That's the first thing.
Yeah, this is important. This is basically the first phase is called what? The handshake. Handshake. Basically, agree on the cipher suite. agree on the keys. Okay, so you need to do that step. Okay, now if you are using encryption authentication, you need to go through that. Even if you are using another protocol like IPsec, you need to do the same thing, something similar. Okay, so this is done through security association. So basically, here the idea of security association is that you have a host A here, okay, host B here, host C here, a lot of them, okay, like maybe tens, hundreds, thousands, okay. If A needs to use IPsec with all those parties, if it needs to exchange data using IPsec with this B, it needs to agree on protocol, okay, cipher, and it needs to agree on the key with B. With C, can it use the same protocols and same keys, etc.? It needs to do the same thing. Okay. Now this agreement, okay, of the ciphers and keys, this is called security association. So basically, A needs to maintain a security association with each other entity. It needs to communicate with IPsec. Okay. So security association is very important to IPsec. IPsec requires a logical relationship called the security association between two hosts. This section, so this is the idea. If Alice needs to communicate with Bob, it needs to have a certain security association with, basically you need two. Because I remember in SSL, if you need to send data in one direction, you need a key for that. If you need to receive data, you will use another key. This inbound and outbound. Same thing here. Alice, if it needs to communicate with Bob, it needs to have two security associations. Okay, one for inbound, one for outbound, one for sending, one for receiving. Okay, and basically you need the algorithm, you need the key, you need all the information related to exchanging data securely. Okay, and of course here we are talking not about 3 or 4 or 5 users. We are talking about hundreds, thousands. So this is why we maintain that security associations into a database. We call it an SAD, Security Association Database. Every user will have a security association database containing the identity of the security parameter index, destination address, the protocol, and then for every destination address here, okay, and you have here all the information required to encrypt, decrypt, etc. Okay. So example of kind of the information here. We have the security parameter index. This one. So it's an index, and this is the same one we put in the packet. When we remember in the packet of ESP and IP and authentication head, we have this security parameter index. Okay. This will tell the destination how to decrypt. You don't need to put all that information here. Okay. You just specify the index of the security association to get the key, etc. The destination, when it opens that, finds that index, it will go to that database, get the entry there, and get all the information to decrypt that message.
Has to be known. All the database.
Known.
Has to be accessed by public.
Not public. No. The user needs to have access to his database. That's it.
His own database.
Yeah, of course. You don't need something else. Okay. Yeah, that's security parameter index. This is the destination address. This is the protocol. Okay. Then you have SN, which is a sequence number, just a sequence number. You have an overflow flag. I forgot what it's used for. Here you have ARW, which is the anti-replay window, the anti-replay window size. Okay, to protect against replay attacks. Okay, you have here the lifetime. Again, I forgot what it's used for. Lifetime of the security association, because security association. It's about encrypting and decrypting. You maintain some keys, and the keys have some duration or expiration period. Okay, so basically the lifetime will specify that. How? Because after, let's say, 5 or 10 minutes, you need to agree on other keys and refresh that, and lifetime will tell you that. Path maximum transfer unit. This is the size of the normally the not the window, the frame, the packet normally. Yeah, the payload, the maximum MTU always maximum transfer unit. Now you tell me, where are the keys? Where are the keys to encrypt and decrypt? Where are the algorithms, the cipher? Okay, that information is here in this column. Okay, authentication ESP. This is the information related to authentication header and ESP. Okay, so the cipher, the keys, which direction if you need to use encryption, the initialization vectors, all those secret information to carry out the cryptographic protocol. Okay. So basically here, if A needs to communicate with, let's say, 100 other users, okay, it needs to have a database containing the information of every security association with each user. Okay, so it will have like 100 entries in this database.
But it has to update this association.
Yeah, of course. It needs to. There is a protocol for it. We will not cover it, by the way. It's in the chapter. We will not cover the agreement, etc. I'll show you what. Yeah, this is details of those information. So basically, the one we didn't it is not even here. Yeah, path MTU. This is about fragmentation. Overflow, sequence number overflow. This is a flag that defines stations option in the event of a sequence number overflow. Yeah, if what happens, you have a sequence number. Sequence number, it starts, let's say, from 1. It reaches a maximum value. When it reaches that maximum value, what happens? Do you restart from the beginning? Do you refresh the security association? What you do here? So basically, the number for that. Okay. And see here, authentication header information, ESP information. This contains the algorithm, the keys, the key lifetime, all. The last aspect, which is the security policy. Security policy. Now, suppose B received a message from A, okay, with IPsec. Let's say with I don't know, ESP, for example. Okay, it contains some data, it contains some headers, etc. Now, it receives a message from B. A, what it will do according to you?
It will decrypt.
It will try to decrypt, right? Yeah. So basically, it will check what are the information required to encrypt. How to do that? How to know which cipher it will use, which key it will use to decrypt that?
From the database.
Association.
Yeah, so it needs to go to the database, and it needs which entry. How to know which entry? There is the index, and there is the IP address. So it will identify, it will tell which security association it needs to use. Now, this does not happen as easy as this. There is what we call security policy, and this basically A will apply something similar to a firewall. Okay, a firewall, how it works? Firewall. When it gets a packet, it does what with that? It needs to take a decision out of that packet. Either discard it, either pass it, either return it, or what to do. How to decide about that? The headers. Okay, the information in the IP header. Source IP, destination IP, source port, destination port, and protocol. 5 information. Okay, it will take a decision. So it looks to in the rules in the firewall. Okay, for these type of headers, the decision is block. I will not accept packets coming from this IP going to this port. Okay, so IPsec will do the same thing. It will not, whenever it receives something from B, it will not accept it and decrypt it right away. It has a policy that tells it what to do with a packet coming from IP of B. Okay, so maybe if something comes from B, discard it. I don't receive message from B. Okay, so here you need what we call security policy database. It's like the firewall rule or the firewall policy. For every, this is basically the same information as we have in the firewall. Source address, destination address, source port, destination port, and protocol. Okay, name I think here, I don't know, name of the association. But these 1, 2, 3, 4, 5, these exactly the information used by the firewall. And here, the policy. The policy, it might be one of 3 things. It might be discard, easy things, always, discard, block, okay? Then you have bypass. Bypass, it means do not decrypt it as, accept it as is. Because it means it's not encrypted or it's not authenticated, no need to do anything with it. No need to check it. Just accept it, pass it to the application protocol right away. Okay. The third policy or decision is apply. Apply. This is the option to apply the IPsec decryption and stuff. Okay. So as I told you, you have this is for outbound. So basically, Alice wants, and this happens in both directions. When you need to send a message, when you need to receive a message. Okay. In outbound, when Alice wants to send a message to Bob, okay, to Bob. So what it does, first it will take that packet, and depending on the IP of Bob, the destination IP, it will take a decision. So there is a policy here. So it will take, according to the IP of Bob, it will look for the security policy entry, and here it will tell it whether to discard or drop, or apply, or bypass. Okay. So here, if for example an IP is trusted, there is an IP Bob is really trusted. We don't even need to use IPsec. So what happens here? The decision will be bypassed. So just send it without encrypting, without protecting. Okay, just send it in plain. Okay. If the Alice is prohibited from communicating with another user, the policy here will be drop. Okay. So Alice, and the system will tell to Alice, you have no. You don't have the right to communicate with that entity. Okay, it will be dropped. Then we have apply. Apply meaning you will encrypt it. So the IP, the destination IP of Bob is, there is an association with it. There is a key. There is protocol. Then we will apply whatever is there. So when we apply, we will use the security policy index. Security SPI.
Association.
It was not. Security parameter index. Security parameter SPI. Security parameter index. Okay. So basically here it will use that security parameter index, and it will look for the entry in the security association database, and we'll get the cipher, we'll get the key, and it will encrypt. Okay. And here we specify also should be used authentication header or ESP. Okay. It will encrypt it. Now, then before, if it finds an index, that is fine. It will do it. Okay. If there is no security association, if it doesn't find that index here, there is no security association. What happens here? What does it mean? It means we need to communicate with that destination using IPsec, but we don't have an association yet. We don't have a key. We don't have a cipher. What should we do? We need to create a security association. We need to agree on a security association, and this is done with the this protocol. There is another protocol completely for that, with establishing security association. It's called the IKE, key exchange. I think it's I forget this. Key exchange. I don't know. This is key exchange, but I don't know. Index exchange or interface.
Integrity.
No. So this protocol is in charge of establishing new security association. In the textbook you have a long part about this. I will not cover it. Okay. A lot of details how to agree. This is the equivalent of SSL handshake. SSL handshake phase. Okay. So if there is no association, we will establish through this protocol. If there is an association, basically we will apply IPsec as we saw. Okay. Now in the reception side, when you receive so the inbound, if you receive a packet, you will do the same thing. First thing, basically you will Yeah, you receive from this. Yeah, you receive from this. Now you check the policy first. What to do with an IP, with the packet received from a certain IP? You have the policy. It might be discard, bypass, or apply. So basically, discard will block it. Bypass, we will not go through IPsec. We will pass it right away to the transport layer. Apply, we'll look for the index in the security association. Now, here's the difference. If we find the security association, we'll do it normal. We'll decrypt it in normal way. If we don't find the security association, what does it mean?
As a receiver?
You are receiving something from someone who is claiming to have a security association with you. But after checking, you don't have a security association with you. So it means it's trying to fool you or something. This is kind of attack. So basically, what we do, if you don't find a security association, you discard, you drop that message. Okay? You don't try to establish a security association because it's useless. Okay? And then if there is a security association, of course, you decrypt it with IPsec. Okay? So all this is happening on the background in transparent way. Even if you don't use a secure protocol, if your system supports IPsec, it will be done on the transparent on the background. Okay. Yes. So let's stop here.